Okay, if you're a clinical researcher, you know the feeling. You've got this mountain of raw data, and the goal is to find that one meaningful, publication-ready insight hidden inside. That journey can feel, well, pretty daunting. We're going to see how we can shrink that whole complex process from hours of work down to just a few simple clicks using this survival analysis tool. So let's just dive right in with a classic scenario. Imagine we've got clinical trial data comparing two treatments, let's call them A and B. Our entire mission for the next few minutes is to get a clear, data-backed answer to one single question. Is treatment B actually better? And to get there, we've got a really clear roadmap. First, we'll set up the data. Then, we'll run the core analysis and actually see what the numbers say. After that, we'll visualize the results, dig a little deeper for any hidden effects and patient subgroups, and finally, wrap it all up so it's ready for publication. Let's get to it. All right, first up, the setup. You know how important this part is? These first few steps are all about laying the groundwork to make sure our final analysis is totally accurate and reliable. First things first, we just upload our raw data file. And right away, the tool gives us this handy preview. It confirms everything loaded correctly. 1,000 rows, 10 columns. This is such a crucial first check. It lets you spot any big formatting problems right from the get-go before you waste a single second on a bad analysis. Next up, we just have to tell the tool what it's looking at. We basically map out our data, telling it which column is for survival time, what counts as an event, like a relapse, and of course, which column defines our treatment groups. We also clarify if other variables like age are numeric, or if something like stage is categorical. This is what sets the stage for the entire analysis. And check this out. This is where the automation is just brilliant. The tool automatically scans for and cleans up messy data. For us, it found and dropped 10 rows that were missing key info. So boom, just like that, we have a clean, analysis-ready dataset with 990 records. A process that could have taken a while to do by hand is just done in seconds. Okay, with our data all prepped and clean, we're ready to get to the good stuff, the core analysis. This is where the tool's statistical engine really fires up and does the heavy lifting, uncovering the story that's hidden inside all those numbers. Now, before we see the results, let's have a quick refresher on our main metric, the hazard ratio, or HR. Just think of it as a measure of risk. If the HR is less than 1, that suggests the treatment is helpful. It reduces risk. If it's over 1, that suggests an increased risk. That's it. Simple as that. So, before we even peek at the outcomes, any good study has to check for balance, right? Are our two treatment groups actually comparable to begin with? This chi-square test confirms that, yes, they are. All these high p-values tell us there are no significant differences in the baseline characteristics. This is so important because it means any difference we see later is likely because of the treatment, not because the groups were unbalanced from the start. Now for the main event, the multivariate Cox analysis. This is a really powerful model that looks at the impact of our treatment while, at the same time, adjusting for all the other patient factors. And the tool gives us everything we need, the detailed table with the exact numbers, and this super intuitive forest plot for a quick visual takeaway. And here we go. This is the number we've been waiting for. After adjusting for everything else, the hazard ratio for treatment B is 0.74. What does that mean? It means patients on treatment B had a 26% lower risk of an event compared to patients on treatment A. That's a pretty significant finding. That hazard ratio is powerful, for sure. But, a picture can tell the story even more clearly. So let's move on to visualizing this result in a way that any clinician can understand in a heartbeat. And here it is, the Kaplan-Meier plot. This is the visual verdict. Just look at that clear separation. The orange line for treatment B is consistently above the blue line for treatment A. This shows a higher survival probability for patients on treatment B, and it holds up over time. That gap, plus that highly significant p-value, well, that's the visual proof you're looking for. So what does this actually mean in the clinic? Well, if you look at the 26-month mark, it translates to a 4% absolute difference in survival probability between the two groups. That's a real, tangible number you can use to communicate the treatment's impact. So, we've established treatment B is better overall. But modern research always asks a deeper question, doesn't it? It's not just, does it work, but who does it work for? Let's dig into that more nuanced story. And this leads us to a really critical follow-up. The overall result is strong, no doubt,
But is that benefit the same for every single patient? Or are there specific subgroups who respond particularly well? This subgroup analysis answers that question instantly. This forest plot breaks down the treatment effect by all these different patient characteristics. And whoa, look at this. The benefit is definitely not the same for everyone. For males, the hazard ratio is a very strong 0.61. For females, it's 0.87. This suggests the treatment is way more effective in male patients. And just like that, you've generated a powerful new hypothesis for future research.
But is that difference we just saw a real thing, or could it just be random chance? Well, that's what interaction p-values are for. They give us the statistical proof. You can see for sex, stage, age, and more, the p-values are incredibly low. And that interpretation, heterogeneous, confirms it. The treatment's effect truly is different and statistically significant across these subgroups.
So think about it. We've gone from just a pile of raw data to a really deep, nuanced understanding of our clinical trial. Now for the final step, taking these insights and turning them into real-world impact.
And this is the part that just makes the whole workflow so efficient. With literally one click, every single table and plot we've just looked at gets exported into a single zip file. It's all formatted and ready to be dropped straight into your manuscript or your next presentation. Think of the time that saves.
So there you have it. We didn't just confirm treatment B is more effective, we found out who it helps the most. We saw how this entire, often painful journey from a messy spreadsheet to a deep clinical insight can be streamlined. And it really just leaves one question. What will you discover in your next data set?